On January 15, the interstellar object 3I Atlas was alleged to have simultaneously disabled 147 nuclear-powered submarines worldwide for exactly 14 minutes and 22 seconds, an event described as a highly calculated action. This incident was believed to have been predicted in advance through binary encoded signals transmitted on the hydrogen line frequency, while at the same time raising serious paradoxes for modern physics, ranging from the limits imposed by the speed of light to the ability of acoustic waves to penetrate solid matter. In addition, a series of further anomalies were recorded, including the fact that 3I Atlas deliberately released millions of microscopic debris fragments, arranged in a precise geometric structure rather than dispersing randomly, forming a calculated trajectory expected to intersect Earth's orbital path within 11 days. These phenomena were accompanied by other difficult-to-explain signatures, such as apparent violations of the law of conservation of momentum, the ability to generate heat independently, and the emission of synchronized radio signals on a large scale. From this body of scientific and military evidence, the text advances the hypothesis that 3I Atlas is not a natural celestial object, but a technologically superior entity, conducting a deliberate demonstration of power aimed at humanity's most destructive weapon systems. Within this context, the appearance of a second unidentified object moving closer to Earth is interpreted as a clear warning that humanity may have officially entered a new and deeply mysterious era of contact with extraterrestrial intelligence. All 147 nuclear-powered submarines operating across the world's oceans were rendered mysteriously and unexpectedly inoperative for exactly 14 minutes and 22 seconds, a duration measured with mechanical precision and recorded independently by multiple naval command systems. The event began without warning alarms or precursor failures, as communication links encrypted burst transmitters and emergency backup channels ceased functioning at the same instant, despite the vessels being dispersed across different depths, oceans and operational conditions. Submarines designed to remain functional under the most extreme scenarios, including full-scale nuclear conflict, entered a state of total communicative silence, unable to send or receive signals yet otherwise maintaining internal stability. No cascading system failures were observed, no power loss was detected, and no internal damage was reported, suggesting that the vessels were not disabled through conventional mechanical or electronic breakdown. The simultaneity of the blackout defied established engineering assumptions, as even global electromagnetic disturbances typically produce measurable delays due to Earth's curvature, seawater conductivity, and signal propagation limits. Yet in this case, the loss of communication occurred with near-perfect synchronization, differing by less than a fraction of a second worldwide. Equally striking was the recovery, as all systems resumed normal operation simultaneously, without reboot sequences or corrective intervention, as if an external constraint had been lifted rather than an internal fault resolved. The absence of any identifiable natural or human-made cause transformed the incident from a technical anomaly into a global mystery, one that challenged existing models of security physics and control over humanity's most protected military assets. When analysts first approached the blackout through probability, they expected comfort from numbers, yet the calculations only deepened uncertainty, because redundancy is designed to dilute coincidence, and coincidence was precisely what the data refused to offer. Each submarine operates within an architecture of layered safeguards, and while individual failures are anticipated and rehearsed, simultaneous collapse across independent systems contradicts the statistical assumptions that govern naval engineering. As models were recalculated and margins expanded, the probability narrowed toward insignificance, and the event crossed from improbable into effectively impossible, while 3 Atlas remained temporally adjacent to the anomaly without occupying a conventional causal role. Redundancy itself became the subject of scrutiny, because layered systems assume independence, and independence fails when an influence operates above or beyond the layers they were designed to resist. Engineers mapped communication pathways and shielding protocols, and while each vessel differed slightly in configuration, the common outcome implied a shared vulnerability that doctrine had never named, as if the architecture itself had been addressed rather than its components. The question then shifted from failure to reach, because redundancy can absorb damage but not intention, and the silence suggested an interaction that bypassed the expected points of resistance. 3 at last entered the discussion not as an actor but as a boundary condition, because the object existed within the same temporal envelope as the blackout, and timing became more persuasive than proximity. Statistical language continued to frame the analysis, and while numbers described likelihood, they also revealed limits, because probability cannot explain coordination without a coordinating mechanism. In technical briefings, redundancy was reframed as assumption, and assumptions were acknowledged as historical artifacts rather than universal truths, because systems evolve in response to known threats and remain blind to unknown ones. 3 Atlas lingered in charts and timelines as an unresolved reference point, and while no direct mechanism had been established, the coincidence of presence and effect resisted dismissal through routine explanation. The blackout demonstrated that survivability does not guarantee autonomy, and while submarines are engineered to endure isolation, isolation itself became the vulnerability when imposed externally. Analysts noted that no recovery protocols were triggered, and the absence of internal alarms suggested that systems had not failed in sequence, but had been held in suspension. Such suspension challenges engineering logic because systems are built to break or to recover, and stasis implies an external constraint applied evenly across disparate platforms. 3 Atlas thus remained part of the analytical frame, not because of accusation, but because exclusion proved impossible, and every model that removed the object left the synchronization unexplained. As probability reached its explanatory limit, inquiry moved towards structure and intent, and the discussion prepared to cross from numbers into mechanism carrying 3I Atlas forward as an unresolved constant. Attention shifted toward the electromagnetic record, because timing alone was insufficient, and investigators traced the blackout's boundary to a signal detected moments earlier. The Deep Space Network logged a structured electromagnetic pulse at 1.42 GHz, and 3 Atlas entered the analytical frame as the only coincident external source. This frequency was not arbitrary in scientific culture, because the hydrogen line has long been treated as a universal marker for interstellar communication. By appearing at that exact wavelength, 3 Atlas intersected with decades of human assumption, and the overlap between expectation and observation created immediate tension. Solar interference was examined and excluded, and terrestrial contamination was ruled out through cross-verification across distant receivers. 3 Atlas therefore remained statistically isolated not as proof of agency, but as an unresolved alignment between signal choice and cultural meaning. Engineers emphasize that natural objects generate broadband noise rather than narrowband structure, and the signal's coherence resisted simple classification. The pulse carried internal modulation rather than random fluctuation, and analysts described it as organized without assigning purpose. 3 Atlas persisted as a reference constant in these discussions, because removing the object from the timeline dissolved the anomaly into coincidence. The hydrogen frequency itself carries symbolic weight in astrophysics, because it marks the most abundant element and the quiet background of the cosmos. When that background becomes active, interpretation shifts, and 3 Atlas appeared to occupy the space between signal and silence. Duration added another layer of complexity because the pulse ended cleanly rather than decaying, and 3 Atlas aligned with control rather than dispersion. Models explored whether the emission could be incidental, yet incidental processes rarely terminate with precision, and this inconsistency remained unresolved. As analysts debated mechanism, the question of audience emerged quietly, because signals imply reception even when no reply is expected. 3 Atlas thus reframed the event from interference to expression, while still avoiding definitive attribution or intention. The electromagnetic record did not explain the blackout, yet it constrained the range of explanations by introducing structure where randomness had been expected. This structure redirected inquiry from environmental cause to informational possibility, and the narrative began to pivot accordingly. 3 Atlas remained central not because of certainty, but because the signal's language overlapped with humanity's chosen listening frequency. The chapter closed with an unresolved alignment between technology and meaning, and the investigation prepared to cross from detection into causality. The most unsettling feature of the blackout emerged not from its duration but from its simultaneity, because every vessel entered silence at the same instant, despite occupying different oceans, depths, and electromagnetic environments. Clocks that should have disagreed by milliseconds instead agreed within a tenth of a second. And while such precision is common in laboratory settings, it is foreign to planetary scale systems exposed to curvature, conductivity, and distance. 3 Atlas entered this phase of analysis as a temporal marker rather than a spatial one, because synchronization implies coordination, and coordination implies a frame that supersedes geography. Physics predicts delay as a rule rather than an exception, and when signals traverse Earth's curvature and seawater density, arrival times should smear into measurable offsets. Yet no offset appeared, and the absence of variance suggested that the event did not propagate outward from a point but descended uniformly as if imposed across all nodes at once. 3 at last remained aligned with the onset by coincidence of time rather than path, and that coincidence resisted explanation through conventional wave mechanics. Engineers tested models involving global electromagnetic coupling, and while Earth's ionosphere can mediate large-scale effects, it cannot erase depth-dependent delay without distortion. The blackout respected no gradient, and the oceans behaved as though distance had briefly lost relevance, which reframed the question from transmission to synchronization. 3 Atlas persisted in timelines as the only external variable that shared the moment without sharing the medium, and this separation intensified rather than resolved the paradox. In distributed systems theory, perfect synchronization requires either a master clock or a constraint that freezes all clocks together. Neither condition exists naturally at planetary scale, and redundancy cannot compensate for the absence of a coordinating reference. 3. Atlas therefore hovered at the edge of inference because its presence suggested a shared reference frame without revealing the mechanism that enforced it. Analysts noted that synchronization does not require energy proportional to distance if distance itself is bypassed conceptually, and this observation unsettled assumptions embedded deep within engineering doctrine. The event behaved less like a signal moving through space, and more like a state change applied everywhere simultaneously, which placed it outside standard models of causation. 3 Atlas became associated with this state change, not through accusation, but through exclusion, because removing the object left no candidate capable of imposing such uniformity. As discussions progressed, language softened from explanation to description, and the blackout was increasingly framed as a condition rather than an attack. The paradox of perfect synchronization closed the chapter by narrowing the field of possibility, because any remaining explanation would need to operate above distance below detection and within time itself. Distance entered the analysis as a quiet constant, because when the blackout timeline was aligned against the sky map, the separation between Earth and 3 Atlas measured nearly 194 million kilometers, while causality demanded patience that the data refused to grant. Light defines that patience, and although electromagnetic influence is constrained by a universal speed limit, the event compressed expectation by beginning 47 seconds after detection, which forced analysts to reconcile clocks rather than trajectories. When timelines were overlaid, Atlas became a reference not by motion but by implication, because any influence travelling from 3 Atlas should have arrived minutes later, yet the blackout respected neither anticipation nor delay. Physics tolerates coincidence only when uncertainty remains large, and uncertainty collapsed here because clocks synchronized with mechanical indifference, while distance remained unchanged, and Atlas stayed far beyond any conventional reach. Engineers recalculated propagation paths through vacuum and atmosphere, and although marginal adjustments could shave seconds from arrival, no configuration could erase 10 minutes without violating assumptions that underwrite modern causality. As the gap persisted, Atlas reappeared as a boundary condition rather than a source, because removing Atlas from the equation left a silence that still began too soon and ended too precisely. The discussion therefore shifted from travel to order, because time can be aligned without movement if a shared frame exists, and such a frame would render distance descriptive rather than restrictive. Atlas hovered within this reframing as a temporal companion, since the object's recorded behaviour intersected the blackout, not by crossing space, but by sharing a moment that resisted spatial explanation. Relativity was invoked carefully, and while no claim of violation was sustained, the models acknowledged that observation can lag cause, which raised the possibility that detection followed consequence rather than preceded it. If detection followed consequence, then at last could be responding rather than initiating, and the 47 seconds would represent echo instead of impulse, while Earth itself became the stage of the primary event. This inversion unsettled established sequencing, because cause preceding observation dissolves the comfort of forward narrative, and Atlas remained implicated without being assigned agency. Time thus emerged as the central variable because distance failed to scale effect and synchronization displaced propagation as the operative concept across oceans and instruments. Atlas persisted through this section, not as an answer, but as a constant presence within a problem that refused linear resolution, while analysts learned that clocks can deceive when frames are misunderstood. The chapter advanced by narrowing possibility rather than asserting mechanism, and as inquiry leaned toward temporal structure, the role of 3 Atlas remained suspended between observation and implication. Faced with the temporal mismatch, 2 hypotheses emerged, and while neither offered comfort, both reframe the role of causality in ways that existing models struggle to absorb. The first hypothesis considered the possibility of faster-than-light influence not as a claim, but as a boundary test because extreme data pressures theory to reveal where assumptions end. Relativity has survived a century of scrutiny, and analysts treated it as resilient rather than fragile. Yet the blackout forced a question about whether influence must always travel as signal. 3 Atlas entered this hypothesis space as a stressor on theory, because assigning superluminal capability to Atlas would fracture not only physics, but the interpretive frameworks built upon it. No model of faster-than-light transmission held without contradiction, and each attempt introduced paradoxes that exceeded the original anomaly, which led investigators to treat this path as illustrative rather than explanatory. Attention therefore shifted toward the second hypothesis, which inverted the sequence entirely and proposed that detection followed consequence rather than initiated it. In this echo framework, the pulse recorded from 3 Atlas would not be the cause of the blackout, but its reflection, a response triggered after an event that had already unfolded near Earth. 3 Atlas thus became a mirror rather than a transmitter in the 47-second interval, transformed from impossibility into delay between action and acknowledgement. This inversion preserved relativity while challenging intuition, because it required accepting that observation does not always align with origin in temporal order. Analysts examined whether Earth-based systems could generate a primary event of such scale without detection, and while no candidate emerged, absence alone could not invalidate the hypothesis. 3 at last remained critical within this model because the object provided the only external confirmation that something had occurred, even if that confirmation arrived late. The echo hypothesis also reframed synchronization because a local event affecting all submarines simultaneously would remove distance from the equation, leaving at last to register the disturbance afterward. Such a scenario implies a coupling between Earth and Atlas that operates outside traditional signaling, yet does not require violation of known speed limits. Investigators explored whether spacetime itself could mediate such coupling, and while speculative, the idea allowed coherence without superluminal motion. 3 Atlas appeared again as a participant in timing rather than causation, because the object's recorded behavior aligned with response rather than initiation. The echo framework also carried philosophical weight because it suggested that humanity detected consequence before cause, reversing the comfort of linear narrative. While neither hypothesis resolved mechanism, the echo model constrained the problem, more gently preserving physical law while expanding interpretation. 3 Atlas thus remained suspended between sender and receiver, and the investigation moved forward with the recognition that understanding might depend less on speed and more on sequence. During the blackout interval, when communication channels remained inert and procedural checks yielded no anomalies, one vessel recorded an event that reframed the inquiry entirely because the absence of signal was interrupted by sound rather than light. The USS Louisiana registered an acoustic pulse through its passive sonar array, and although the crew could neither transmit nor receive the vessel, continued to listen while 3 at last remained temporally aligned with the moment of detection. The pulse did not resemble environmental noise or mechanical interference, and as analysts later reconstructed the waveform, they noted structure where randomness should have prevailed, because the signal carried ordered information rather than chaotic pressure. Within that structure, the pulse encoded operational parameters specific to the USS Louisiana, and the data mirrored classified specifications with precision that exceeded internal diagnostic access, while 3 Atlas lingered as the only coincident external reference. Depth-heading propulsion characteristics and resonance signatures appeared within the acoustic pattern, and each parameter matched records held in secure systems that do not interface with sonar input. The improbability of such correspondence redirected attention from detection to knowledge, because knowing a system is categorically different from influencing it, and 3 Atlas became associated with awareness rather than force. Geography complicated the analysis further because the acoustic path traced backward from the submarine did not terminate at the surface or another vessel, but projected upward through Earth's mass along a vector that intersected the sky. That vector, when extended beyond the planet, aligned with the region occupied by 3 Atlas, and while alignment alone does not establish origin, it constrained the range of plausible explanations. Sound cannot traverse solid planetary material without attenuation beyond recognition, and yet the pulse arrived intact, which suggested a transmission modality that used acoustic form without acoustic limitation. 3. Atlas thus entered a different interpretive category, because the event implied not only detection but translation, converting inaccessible information into a medium the submarine could perceive. Analysts debated whether the sound was a carrier or a representation, because the data might not have travelled as sound at all, but arrived as a transformation of another interaction. If so, then 3 Atlas would not need to project energy through Earth, but only to trigger a local manifestation that reflected internal knowledge outward. This possibility unsettled conventional boundaries between sensing and signalling, because it implied access without penetration, and 3I Atlas remained adjacent to that implication by timing rather than proximity. The absence of damage during the event reinforced the interpretation of demonstration rather than attack, because revealing knowledge communicates capability without escalation. 3 Atlas thus appeared not as an adversary in the acoustic record, but as an observer capable of reflection, and reflection carries intent without motion. As this section closes, the presence of sound within silence reframes the blackout as an exchange rather than a failure, and the role of 3 Atlas shifts from anomaly to participant within a system that listens back. The blackout concluded with mechanical precision, and while systems resumed their expected functions without error, attention shifted outward as instruments registered an emergence that reframed the event beyond recovery. Within minutes of restoration, infrared sensors detected a thermal bloom in deep space, and although no prior trajectory had been logged, the object manifested with defined dimensions and energy output. 3I Atlas re-entered the narrative at this moment because the appearance aligned temporally with the end of silence, and coincidence accumulated faster than explanation. The newly detected body measured approximately 340 meters in length, and its surface temperature exceeded 800 Kelvin, which placed it beyond the thermal behavior of inert debris. Unlike transient flares or fragmentation signatures, the object exhibited stability, and its emission pattern suggested sustained power rather than residual heat. 3 Atlas became context rather than cause in this frame because the second object appeared not as an extension, but as a companion phenomenon. No survey data indicated approach or formation, and orbital analysis failed to trace an origin vector, which implied either concealment or emergence beyond detection thresholds. The absence of historical data challenged confidence in monitoring systems, and the realization settled that visibility itself may be conditional rather than absolute. 3 Atlas shared the observational window with this second presence, and the paired configuration suggested structure over randomness, without specifying hierarchy. Strategic analysts noted the selective nature of the prior blackout, and when combined with the emergence of a secondary object, the pattern began to resemble signaling rather than interference. Nuclear submarines represent deterrence rather than communication, and targeting their connectivity without collateral disruption reframes power as restraint. 3. Atlas thus appeared adjacent to a message defined by limitation, because demonstrating control without destruction communicates capability more effectively than force. The second object amplified this interpretation, and while it did not interact directly with Earth, its sudden visibility functioned as punctuation rather than escalation. In deterrence theory, visibility matters as much as reach, and the sequence suggested that observation itself had become part of the exchange. 3 Atlas remained central to inference because its continued trajectory and non-gravitational behavior paralleled the appearance without converging upon it. Together, the objects defined a configuration that implied coordination without disclosure, and ambiguity became the medium through which meaning was conveyed. This section closes not with threat, but with boundary, because the message embedded within emergence favors awareness over action, while 3 Atlas persists as a reference for restraint rather than aggression. When attention returned to 3 Atlas after the emergence of the second object, investigators focused on a development that appeared procedural rather than reactive. because at last initiated a release event that unfolded with timing more reminiscent of machinery than geology. The release did not occur as a single outburst, and while natural fragmentation typically produces chaotic dispersion under thermal stress, 3 at last emitted material in a measured sequence with discrete intervals separating each ejection. Data from multiple observatories showed that the intervals averaged 114 seconds, and although minor variance existed, the consistency remained well within tolerances associated with engineered systems rather than stochastic processes. 3 at last therefore entered a different analytical category, because the release sequence suggested scheduling, and scheduling implies control rather than response. Astronomers compared the event to known cometary behaviour, and while outgassing can appear episodic, it does not align with clock-like regularity across multiple emission points. In contrast, 3 at last exhibited 12 distinct release loci distributed across its surface, and the activation of these loci followed an order that repeated without overlap. This behaviour challenged the assumption that surface composition alone governs emission, because composition cannot account for synchronized timing across spatially separated points. 3 at last thus appeared to operate under an internal logic that treated its surface not as a boundary but as an interface. Mechanical precision became the defining feature of the sequence, and analysts noted that the release neither accelerated nor decayed over time, which eliminated thermal runaway as a primary driver. Instead, the process resembled throttled output, and throttling implies regulation while regulation implies feedback. 3 at last remained consistent throughout the event, because its trajectory and rotation showed no disruption, which further undermined natural explanations. The absence of recoil during emission added another layer of complexity because momentum transfer should manifest as measurable deviation, yet Atlas maintained course, as if mass redistribution had been internally compensated. Investigators considered whether unknown material properties could account for this behaviour, but material novelty alone cannot produce temporal coordination without a governing mechanism. 3. At last therefore stood at the intersection of material anomaly and procedural behaviour, and the convergence of those domains intensified scrutiny. As the sequence progressed, the release pattern resolved into a recognisable cadence, and cadence suggests intention without revealing objective. 3 at last did not accelerate the event, and it did not conceal it because visibility appeared deliberate rather than accidental. This combination of exposure and control reframed the release as demonstration rather than byproduct, while 3 at last remained present as the constant executor of sequence. By the end of the emission cycle, the question was no longer whether the event could be natural, but whether natural language was sufficient to describe it. The section closes with the recognition that precision itself had become the anomaly, and that 3 at last had introduced timing as a form of expression rather than consequence. As the debris field expanded away from 3 at last, spatial analysis replaced temporal scrutiny, and patterns emerged that resisted classification as random dispersion, while inviting comparison to structures long familiar in mathematics and biology. High-resolution imaging revealed that the fragments did not radiate outward evenly, and when plotted against angular position, the distribution traced a logarithmic spiral rather than a spherical cloud. This geometry carried immediate implications because logarithmic spirals recur across natural systems that grow or optimize rather than explode, and the appearance of such a form in orbital debris unsettled assumptions about accidental release. 3 at last re-entered the center of interpretation as the spiral resolved further, because the spacing between fragment arms aligned with ratios approximating the golden mean, and this alignment exceeded what stochastic variation could plausibly generate. Astronomers recalculated the likelihood of Fibonacci-like spacing emerging from uncontrolled fragmentation, and while natural phenomena can echo mathematical ratios over time, instantaneous formation at astronomical scale lacks precedent. The spiral persisted across observational frames, and as rotation and parallax were corrected, the structure remained coherent, suggesting that perspective alone could not account for the appearance. 3. Atlas therefore became associated not only with emission, but with arrangement, because arrangement implies foresight rather than aftermath. In nature, Fibonacci patterns emerge where efficiency governs growth, such as in phyllotaxis or shell formation, yet debris fields are governed by force and momentum rather than optimization. The contradiction between expected chaos and observed order redirected inquiry toward design without invoking purpose, because structure can exist without message while still implying constraint. 3. Atlas occupied that constraint by proximity of origin, because no other reference point shared both timing and geometry with the field. Spectral analysis showed no variation in composition that could induce selective spacing, and gravitational modelling failed to reproduce the spiral without introducing non-physical parameters. The geometry thus resisted reduction to material property, and the pattern remained intact even as individual fragments drifted, preserving relational order while allowing motion. 3. Atlas continued along its trajectory unaffected, and the debris maintained proportional spacing relative to a centre that no longer exerted visible control. This persistence suggested that the structure was encoded at release, rather than enforced afterward, because maintenance without feedback contradicts dynamic control models. The spiral invited symbolic interpretation, yet analysts resisted symbolism because meaning cannot substitute for mechanism, even when form evokes familiarity. 3I Atlas nonetheless anchored the discussion, because the object represented the only plausible locus where mechanism could originate without external intervention. As the section concludes, the Fibonacci geometry stands as neither proof of intention nor accident, but as an ordered anomaly that reframes debris as configuration. Within that configuration, 3I Atlas appears less like a fragmenting body, and more like a source of pattern dispersion, and pattern itself becomes the question carried forward. As investigators quantified the debris release from 3I Atlas, momentum emerged as the quiet variable that refused to reconcile observation with expectation, because classical mechanics predicts recoil whenever mass is expelled. In any closed system, conservation of momentum requires that ejected material impart an equal and opposite reaction, yet 3I Atlas maintained its trajectory with negligible deviation throughout the release sequence. Calculation showed a measurable deficit, and while minor discrepancies can arise from modelling uncertainty, the shortfall exceeded tolerance by more than 30%, which placed the anomaly beyond rounding error. 3. Atlas thus appeared to violate not a peripheral assumption, but a foundational principle, because momentum is not a guideline, but a constraint embedded in every interaction we observe. Engineers attempted to distribute the missing momentum across unobserved vectors, and while gravitational coupling and radiation pressure were tested, none could absorb the deficit without introducing effects that instruments would have detected. The paradox sharpened as models matured because adding complexity only increased the mismatch, and 3I Atlas remained dynamically stable, despite acting as a source of large-scale mass redistribution. One hypothesis suggested that momentum was conserved internally through counterflows or mass exchange within 3I Atlas, yet such mechanisms require internal structures capable of rapid reconfiguration. If such internal compensation existed, then 3I Atlas would function less like a passive body and more like a regulated system because balance was maintained without external evidence of stress. Another hypothesis explored whether momentum was transferred into a medium not currently measured, such as spacetime curvature or exotic fields, and while speculative, this avenue preserved conservation by expanding its domain. 3I Atlas occupied the centre of this speculation, because invoking unseen reservoirs without a triggering source would dissolve explanatory rigour. The absence of rotational perturbation further constrained interpretation, because even asymmetric internal flows should have altered spin characteristics over the duration of emission. Yet 3I Atlas rotated with continuity, and continuity implied that whatever mechanism governed the release also governed stability. As analysts compared this behaviour to propulsion systems, parallels emerged without convergence, because propulsion trades mass for motion, while 3I Atlas traded neither in observable form. The event therefore resisted classification as thrust, and it resisted classification as fracture, because neither category accommodates missing momentum without consequence. 3I Atlas remained present in every iteration of the models because removing the object left no locus where the paradox could originate or resolve. This forced a reframing of the problem from violation to translation, because momentum may have been conserved in a form that current instruments cannot yet register. If translation occurred, then 3I Atlas demonstrated not defiance of physics, but access to layers of interaction that physics has not fully charted. The section closes with restraint rather than conclusion, because the paradox does not demand abandonment of conservation, but it demands humility about where conservation may operate when 3I Atlas acts as the reference. As attention shifted from the release mechanism to the fragments themselves, the debris fields surrounding 3I Atlas ceased to be treated as passive residue, and instead became the primary subject of inquiry. Initial assumptions framed the fragments as inert material yet spectral, and thermal readings complicated that view because each fragment exhibited behaviour inconsistent with rock ice or any composite catalogued within known cometary bodies. Measurements showed that fragments as small as millimetres emitted thermal signatures independent of solar exposure, and while residual heat can persist briefly, the persistence observed here exceeded decay models by orders of magnitude. 3 at last remained central to interpretation because the fragments mirrored properties implied by the parent body rather than diverging from them through degradation. Composition analysis revealed complex molecular structures that resisted classification, and although exotic chemistry has precedent in interstellar material organization at this scale, suggested more than chemical novelty. The fragments behaved less like broken matter and more like distributed units, and the distinction became difficult to ignore as emissions synchronized across spatial separation. 3 at last reappeared in comparative models because the debris retained proportional spacing relative to the original release geometry, as though relational awareness persisted after separation. Thermal emissions followed a narrow band rather than a gradient, and the uniformity implied regulation because uncontrolled fragments would diverge thermally as they rotated and drifted. Investigators considered whether the fragments could house microstructures capable of energy management, and while such speculation stretched existing fabrication concepts, it preserved continuity with the observed data. 3 at last thus became associated not with fragmentation, but with distribution, because the debris field behaved as an extension rather than a remnant. Further analysis showed that the fragments responded coherently to external observation, because emission patterns sharpened when instruments focused collectively, a correlation that remained unresolved but persistent. The possibility that the fragments functioned as nodes within a broader system emerged gradually, because synchronization does not require intelligence, but does require communication. 3i. Atlas anchored this hypothesis because the object provided a plausible origin for protocols that could propagate into smaller units without losing coherence. Unlike biological spores or mechanical shrapnel, the fragments demonstrated neither random decay nor environmental dependence, and this stability shifted interpretation away from natural dispersal. If the fragments were designed to persist, then endurance rather than impact would define their role, because longevity enables observation without intrusion. 3 Atlas remained consistent throughout these interpretations, because the object's own resilience mirrored that of the debris, reinforcing continuity across scale. The absence of aggressive interaction further constrained meaning, because nothing in the fragment behavior suggested collision, penetration, or contamination. Instead, the fragments occupied space as though presence itself was sufficient, and that sufficiency reframed them as instruments of context rather than tools of action. As this section closes, the debris field stands neither as threat nor artifact, but as distributed evidence, while 3 Atlas persists as the organizing principle that binds microstructure to macro behavior. As the behavior of the fragments continued to resist reduction to passive matter, investigators began to frame the debris field as a system rather than a collection, and within that frame the hypothesis of a micro-intelligent network emerged cautiously. The hypothesis did not require consciousness or intent, because coordination alone can arise from rule-based interaction, and the observed synchronization suggested that each fragment responded to shared constraints rather than isolated stimuli. 3 Atlas remained the reference anchor because the debris originated from Atlas and preserved relational structure after separation, which implied that whatever governed the fragments predated their release. Radio observations intensified this interpretation because emissions from the fragments appeared in coordinated bursts rather than random spikes, and the timing precision exceeded what environmental coupling could easily explain. When plotted collectively, the emissions formed patterns that repeated across observation windows, and repetition implies protocol, while protocol implies design without necessitating agency. 3. Atlas thus functioned as a plausible root node not because control was observed directly, but because hierarchical emergence is consistent with distributed systems that inherit rules from a central source. Analysts compared the behavior to mesh networks used in terrestrial technology, where nodes operate autonomously while maintaining coherence through minimal signaling. In such systems, no single node carries authority, yet the network behaves as a unit, and this analogy preserved explanatory economy while remaining speculative. 3 Atlas re-entered the discussion as the system initializer rather than the system operator, because the fragments continued their coordinated behavior even as distance increased. This persistence suggested that the network did not rely on constant instruction, but on embedded rules that governed interaction once activated. The scale of synchronization further constrained interpretation, because coordinating millions of nodes requires either extreme bandwidth or efficient encoding, and efficiency was evident in the narrow frequency range observed. 3 at last remained associated with that efficiency because the same hydrogen line frequency appeared repeatedly linking parent body and fragments through shared communication logic. Critically, the hypothesis did not assert intelligence in the human sense, because intelligence can manifest as optimization without awareness, and the data supported optimization more readily than cognition. The fragments responded as though they shared a goal state, yet the nature of that state remained undefined because no change in trajectory or behavior followed observation. 3 Atlas therefore anchored a hypothesis centered on coherence rather than command, because the network behaved as though stability itself were the objective. Such a system would not need to act because presence alone could satisfy its function, especially if observation were the intended interaction. As this section closes, the micronetwork hypothesis remains provisional, because it explains coordination without escalation, and it situates 3 Atlas as the origin of structure rather than its constant overseer. Trajectory analysis became unavoidable once the debris field released by 3 Atlas expanded beyond local context because motion transforms structure into consequence when paths intersect with inhabited space. Orbital models compiled independently by multiple agencies converged on the same projection, and while margins of error narrowed with each update, the central geometry remained unchanged. The debris field associated with 3 Atlas was not drifting randomly through the inner solar system, but was instead aligned along a corridor that Earth would occupy, within a finite and measurable window. This alignment did not imply impact by default because intersection in orbital mechanics describes shared position rather than collision, yet shared position carries implications when objects persist rather than dissipate. 3 Atlas remained central to interpretation because the parent trajectory governed the initial conditions from which all fragment paths evolved. Simulations accounted for solar radiation, pressure, gravitational perturbation, and differential mass, and while each factor introduced minor dispersion, none altered the convergence toward Earth's orbital plane. As days progressed, updates reduced uncertainty rather than expanding it, and confidence in the intersection window increased as observational baselines lengthened. 3 Atlas appeared again as a stabilizing reference, because despite fragment complexity, the overall geometry retained coherence relative to Atlas's original motion. The projected encounter was not framed as arrival, because arrival implies destination, and the data supported passage rather than approach. Yet passage itself demands attention when accompanied by persistence, because persistent systems interact with environments even when interaction is not their stated function. 3 Atlas therefore anchored the question of intent indirectly, because the object's earlier behaviors suggested selection rather than drift, and selection reframes coincidence as choice. Analysts examined whether gravitational capture or atmospheric entry were plausible outcomes, and while neither was supported by current parameters, exclusion did not equate to reassurance. The fragments would traverse Earth's orbital space at velocities consistent with interplanetary transit, and although relative speeds varied, the encounter would unfold over hours rather than moments. 3 Atlas remained associated with restraint rather than urgency, because nothing in the trajectory suggested acceleration toward Earth or correction toward impact. This absence of adjustment implied confidence in initial conditions, because systems that correct course reveal feedback while systems that do not reveal design margin. Earth's motion was treated as a variable, rather than a target, because the planet's predictable orbit rendered interception inevitable, without requiring pursuit. 3. Atlas thus framed the event as a test of coexistence rather than confrontation, because intersection without collision preserves ambiguity. As the section closes, the trajectory analysis does not forecast disaster or contact, but it establishes proximity as a fact rather than a fear, while 3 Atlas remains the silent architect of alignment. As the debris field associated with 3 Atlas approached interpretive proximity rather than physical certainty, analysts converged on 3 scenarios that framed the event without collapsing it into conclusion. The first scenario treated the entire sequence as an extreme natural phenomenon, and while this path preserved continuity with known science, It required revisions so extensive that established physical models would need redefinition rather than extension. In this scenario, 3 Atlas would represent a class of interstellar object whose properties exceed current catalogues, and the debris field would function as an expression of exotic matter rather than intent. Such a revision would not diminish the event because rewriting physical law alters humanity's understanding of the universe more profoundly than any single encounter. The second scenario interpreted the observations as a technological demonstration, and while this framing introduced agency, it did so without assigning motive or hostility. Within this model, 3R Atlas would operate as a probe or platform, and the debris field would act as instrumentation rather than payload. Demonstration without damage aligns with signaling theory, because capability can be communicated through restraint, and restraint preserves ambiguity while establishing a symmetry.